All right, everyone, welcome back. Ready to geek out on some more cool tech stuff. Today, we're diving deep into the world of plastic injection molding.
Sounds exciting.
It is. I mean, think about it. So many of the things we use every day, from our phones to our cars, are made using this process.
It's really quite remarkable how much of our world is shaped by injection molding.
Absolutely. And by the end of this deep dive, you'll not only know how it works, but you'll be able to spot an injection molded part from a mile away. But first, let's bring in the expert.
Happy to be here.
So let's break down this process. What's the first thing that comes to mind when you think about injection molding?
For me, it all starts with the mold.
The mold, huh? Okay, tell me more about that.
Well, imagine you're designing, let's say, a new phone case. The mold is essentially a high-tech cookie cutter for the plastic. It's usually made of steel or aluminum, and it's meticulously crafted to create the exact shape and details of your final product.
So it's the foundation of the whole process.
Exactly. And the plastic gets injected into this mold under immense pressure, filling every nook and cranny.
Whoa, immense pressure. It sounds almost violent.
It is a powerful process, but also very precise. Think about the level of detail on your phone case. Those perfectly formed buttons, the camera cutouts, it's all thanks to the precision of the mold and the injection process.
Okay, so we've got our mold and we're injecting this molten plastic into it. Then what happens?
Well, this is where things get really interesting. We need to cool and solidify that plastic.
Kind of like baking a cake, right? You don't want it to collapse in the middle.
That's a great analogy. If the plastic cools too fast or unevenly, you could end up with defects like warping or sink marks. So controlled cooling is absolutely critical.
So there's a delicate balance there, making sure it cools just right.
Exactly. And once the plastic is completely solidified, it's time for the grand finale, the ejection process.
Oh, right, getting that freshly molded part out of there.
Yep. Small pins within the mold push the finished part out, sort of like popping an ice cube out of a tray.
And voila, you've got yourself a brand new phone case ready to protect your device. But how does this process change when you're making something on a much larger scale? I mean, we're talking about everything from tiny Lego bricks to complex car parts.
That's where the type of mold and the material it's made from become even more crucial. For smaller production runs, maybe you're a company prototyping a new product, you might use a mold made from aluminum.
So it's less expensive to make, easier to modify if you need to tweak the design. Makes sense.
Right. But as production volume increases, you'd probably switch to a pre-hardened steel mold. It's a good compromise between cost and lifespan.
And for those massive production runs, like millions of Lego bricks.
You go with hardened steel all the way.
Hmm.
Those molds need to withstand constant use, making sure each Lego brick is identical and, of course, fits perfectly with all the others.
It's amazing how the type of mold plays such a big role in the whole process. But it's not just about scale, right? The level of detail those molds can capture is unbelievable.
It really is. One of the biggest advantages of injection molding is the precision and complexity you can achieve. It would be incredibly difficult, if not impossible, to get that level of detail with other manufacturing methods. Let's take a look at a technique called overmolding. Ever notice how some toothbrushes have that grippy handle?
Yeah, I love those.
That's probably done with overmolding.
So you're essentially molding one plastic part and then molding another layer of a different type of plastic right on top.
Precisely. And this allows you to combine different materials and textures. And then there's insert molding. Imagine placing a metal component, like a threaded insert, directly into the mold before injecting the plastic.
Wow. So you're embedding a completely different material into the plastic part.
You got it. It opens up a whole world of possibilities for designers. Those buttons on your phone, the intricate housings for electronics, a lot of those fine details are achieved using insert molding.
I'm starting to see injection molded parts everywhere now. My desk lamp, my keyboard, the housing for my headphones, they all have those telltale signs.
You're developing that injection molding eye. It's amazing how much of our everyday world is shaped by this process.
Okay, so now that we've got a good handle on the process itself, I want to know the secrets. How do we spot an injection molded part like a pro? What should we be looking for?
Well, one of the first things you'll probably notice is that smooth, almost polished surface finish. Injection molding often produces parts that don't need a lot of extra work, unlike other methods where you might have to do a bunch of sanding or polishing.
So that's one telltale sign. Got it. What else should we be on the lookout for?
Pay attention to the shape, how complex it is, and the details. If you look at it and think, wow, that would be crazy hard to make using like traditional methods, chances are it's injection molded.
It's like those hidden clues you mentioned before, right? The weld lines, injection marks, and ejector marks. I'm ready to put on my detective hat.
I love it. All right, let's start with weld lines. You know those faint lines where the molten plastic kind of met in the mold but didn't fully blend together?
Yeah, I think I've seen those before.
So they're not always a big deal. But if a weld line happens to be in a spot where the part's going to be under a lot of stress, that could be a weak point.
Makes sense. Like a little warning sign for engineers, right? Hey, maybe reinforce this area.
Exactly. Okay, next up, injection marks. Those are those super subtle lines or streaks that get left behind as the plastic flows into the mold.
They're like the plastic's fingerprints almost.
Uh-huh, yeah, you could say that. And finally, we've got those little ejector marks. Those are the small depressions from the pins that push the finished part out of the mold.
Oh, right. So basically, where it gets popped out.
Yep. And their location can actually tell you a lot about how the part was positioned in the mold.
Wow. So all these tiny marks are like a secret language telling us how the part was made?
Exactly. It's like you said, putting on your detective hat and decoding the story of the part.
You know, we touched on this a bit earlier, but the environmental impact of all this plastic,
Yeah.
it's a big deal these days, right? I'm curious to know more about the sustainability side of things.
It is, definitely. It's something the industry's really focused on, and there's a lot of progress being made. One of the key areas is reducing waste. We talked about recycling, but companies are going even further. They're using sophisticated software to design molds that use the absolute minimum amount of plastic needed.
Smart. Minimizing waste right from the start. I like that.
Yeah, it's a big step. And then there's the whole world of bioplastics. These are plastics made from renewable sources like plants, a more sustainable option compared to the usual petroleum-based plastics.
I've heard that term bioplastics before, but to be honest, I'm not sure I fully get it. Are they really a green solution, or are there downsides?
It's tricky. Some bioplastics can break down naturally in the environment. Those are biodegradable. Others need specific conditions, like industrial composting facilities, to break down. Those are compostable. But there are definitely challenges.
Like what?
Well, some bioplastics need those special composting facilities, which aren't exactly everywhere, and some types. Making them can still have a pretty big environmental impact, even if they're from plants.
So it's not a perfect solution, but it's progress, right?
Definitely a step in the right direction.
Mm.
And research is ongoing to develop even better bioplastics and make the whole process more eco-friendly.
That's good to hear. So it seems like the industry is really trying to make things better for the environment.
Oh, yeah, absolutely. It's all about finding that balance, efficiency, performance, and sustainability. It can't be just one or the other.
Well, we've covered a lot of ground today, haven't we? The ins and outs of injection molding, those tiny marks, even the sustainability aspect. It's been fascinating.
It really has. We've just scratched the surface, though. There's so much more to explore.
I can't wait to see what we uncover in our next deep dive. But before we wrap up this one, I'm curious, what surprised you the most about what we've learned?
Honestly, it's the versatility of injection molding. It's everywhere. It's in medical devices, the cars we drive, the toys kids play with, you name it.
It's true. It's easy to overlook, but it's having this huge impact on our lives every single day. What about you? What stood out to you?
You know, what struck me is that even something as simple as a piece of plastic, it has this whole backstory, this whole world of science and engineering behind it.
Yeah.
It's like a reminder to never stop being curious, you know? There's always something new to learn all around us.
Couldn't agree more. The more you learn, the more you realize there's so much more out there to discover.
And on that note, we've reached the end of part 2 of our deep dive into the world of plastic injection molding. But don't worry, we're not done yet. In part 3, we'll be looking at real-world applications, like how injection molding is being used in everything from medical devices to aerospace.
We'll be getting into the nitty-gritty of its use in medical devices, aerospace, and so much more. And of course, we'll talk about the challenges and the exciting possibilities that lie ahead for this incredible technology. All right, everybody, welcome back for the final part of our deep dive into plastic injection molding. We've gone through a whole process now, seen how it works, even learned to spot those telltale signs on everyday objects. But now I want to talk about how it's used in the real world. Like, what are some of the cooler applications out there?
Oh, there's so many. It's really amazing how versatile injection molding is. We've talked a lot about consumer products, but think about medical devices for a second. Syringes, inhalers, even parts for prosthetic limbs. A lot of that stuff relies on injection molding to make those really intricate parts. And they have to meet some pretty strict standards too, right? Especially in the medical field.
Right, of course. It's pretty amazing how this process is helping people and, actually saving lives in some cases.
Yeah, it's incredible. The level of precision you need for medical devices is insane. We're talking about teeny tiny parts for surgical instruments, implants, even drug delivery systems.
Hmm.
It has to be so accurate every single time. It's crucial.
It's like a whole other world of microscopic engineering, isn't it? And it's all happening thanks to injection molding.
Exactly. And speaking of really demanding applications, we got to talk about the aerospace industry. Those parts on planes and spacecraft. They go through some serious stuff. Extreme temperatures, crazy pressure, and they got to be super strong but also lightweight.
Yeah, no room for error when you're dealing with flight.
Nope, none at all. Injection molding lets you create those super complex, high-strength parts that can handle all that. Things like housings for sensitive electronics,
Mm.
or those lightweight panels they use inside planes. Even parts for rocket engines.
Wow. So we've gone from everyday stuff to medical devices to things that are actually going into space. That's a pretty wide range, huh? But I guess, like any technology, there are always going to be challenges, right? And new things to figure out.
Yeah, for sure. The world's always changing, and injection molding has to keep up, right? One of the biggest challenges is just the constant need to innovate. Like, how do we make parts even stronger, lighter, more sustainable, and of course, more cost-effective? That's always a factor.
So what's next? What are researchers and engineers working on? What's the future of this whole thing?
Well, one area that's really exciting is new materials. We talked about bioplastics earlier, but there's a lot of research going on into even more sustainable and high-performance polymers. Imagine plastics that could, like, heal themselves
Yeah,
or conduct electricity. Crazy stuff.
that does sound pretty wild. It seems like we're just getting started with what plastics can do.
Totally. And another big area is automation and what they call Industry 4.0. More and more factories are using robots and smart technology in their injection molding processes.
Oh, so like robots making robots.
Exactly. And that kind of technology makes things way more efficient, more precise, and you get better quality parts in the end.
It makes you wonder, what will they come up with next?
Who knows, right?
Hmm.
But I'm sure it'll be exciting.
Well, I think it's safe to say we've covered a ton of ground in this deep dive. We started with the basics, learned how to decode those hidden marks, and even got a glimpse into the future of this whole technology.
I hope our listeners have a better understanding of how complex and, important plastic injection molding really is. It's one of those things that's easy to take for granted, but it really does shape our world.
I know I do. I don't think I'll ever look at a piece of plastic the same way again. Now I'm going to be looking for those weld lines and injection marks everywhere, and I'll be thinking about all the engineering and science that went into making it.
It's a good reminder that there's always a story behind things, even the everyday objects we use.
Absolutely. Well, that brings us to the end of our deep dive into plastic injection molding. But hey, the learning doesn't stop here. Stay curious, keep exploring, and who knows what you'll discover next. Until next time, happy exploring, everybody.